So our topic for this morning is reducing ratios to lowest term. So again, when we talk about ratio, we are saying that ratio is a comparison, right? It's a comparison of two quantities. Okay, so a ratio always express a certain rate. And this rate is what we call the comparison of two quantities. That is what we learned last meeting. Okay? And so, how do we now express ratios to lowest terms? So, in order for us to reduce ratios to lowest term, first is you write the ratio in fraction form. Afterwards, you get the GCF, or the greatest common factor of the numerator and the denominator. Once you have done that, you divide both the numerator and denominator by the GCF. And then, write your answer back in column form. So I have here some examples. I have here 3 examples that we will be reducing to lowest terms. So let's take the first ratio, which is 16 is to 20. So according to the steps, what we will do is, first, we write the ratio in fraction form. And in order to do that, we will put 16 as the numerator and then 20 as the denominator. And then for the second step, we now get the GCF of the numerator and the denominator. And in order to get the GCF, we have actually 3 methods, right? We are done with this one. We can use the listing method, we can use the prime factorization method, or we can use the continuous division method. So let's try using first the listing method for us to be reviewed on this. So I'll just put it here on this side so that you won't get confused. So this is the solution area, or the scratch area. So we have here 16 over 20. So we will now get 16. What are the factors of 16? So I'll list down the factors of 16. We have 1 times 16. We also have 2 times 8. And we also have 4 times 4. So I'll just put 4 there. For 20, we have 1 times 20, 2 times 10. We also have 4 times 5. So, do we still have more? Wala naman na. Wala na. Okay. So, these are all the greatest, or so these are all the factors of 16 and 20. Now, we need to look for the greatest common factor. So, what are the common factors? The common factors are 1, 2, and 4. And among 1, 2, and 4, which is the GCF, or which is the greatest? So, the greatest is 4. Therefore, the GCF is 4. And so, we'll go to step 3, which is dividing both the numerator and the denominator by the GCF. So, we will have here, I will divide 16 over 20 by 4 over 4. And then our answer will be 16 divided by 4, which is 4, and 20 divided by 4 is 5. So if you can see, 4 and 5 are already primes of each other. Only one can divide both of them. Hence, this is already already expressed in lowest terms. Did you get that? Okay, let's now go to another example. Let's go to number 2. We have 25 is to 100. So I will write it 25 over 100 because that is according to the first step. We write the ratio in fraction form. And then, let us go back to our scratch portion. We'll now get the GCF of 25 and 100. So we have here 25 and 100. So this time, just for review, I will use the the prime factorization method in order to get the GCF. So 25, the prime factors of 25 is 5 times 5. For 100, the prime factors of 100 is, because 100 is 10 times 10, so I will have 2 times 2 times 5 times 5. Because 2 times 5 is 10, 2 times 5 is 10, 10 times 10 is 100. Now, we now encircle the common prime factors. So I have here one common prime factor and another common prime factor. And in order for us to get the GCF, we simply multiply all the pairs that we have encircled. So we have one pair of 5 and another pair of 5. Hence, the GCF is 25. And that will be part of our step 3. I will divide 25 over 100 by 25 over 25. So 25 divided by 25 is 1. 100 divided by 25 is 4. And this is now the lowest form, or the lowest term form of 25 is to 100. Oh, I forgot. We have to do step 4 pala, writing the answer back to column form. So our final answer should be 4 is to 5 for the first example. And for the second example, the answer should be 1 is to 4. So Miss Tanya forgot about that. Okay. So last example, for number 3, we have 45 is to 9. So we write here 45 over 9. And back to our scratch portion. So I will write here 45 over 9. And this time, I will use the continuous division method, just for you to remember how these processes are done. So I will write here 45 and 9, and I will think of a prime number that divides both of them. So I will divide 45 and 9 by 3, because both of them can be divided by 3. So what is 45 divided by 9? 45 divided by 3. So 45 divided by 3 is 15. So I will write here 15 at the bottom. 9 divided by 3 is 3. 15 and 3 can still be divided by 3. So I will put 3 here. And then 15 divided by 3 is 5. And 3 divided by 3 is 1. Now, looking at 5 and 1, I cannot divide them anymore by any number aside from 1. Therefore, I will have to stop, and I will encircle all the divisors that I made. And then I multiply them. So the GCF here is 3 times 3, which is 9. And then I will have to go back here in our question and divide the whole equation by, the fraction by 9. So we will have 45 divided by 9, which is 5, and 9 divided by 9, which is 1. So if I put that in the ratio form, or in the column form, as for step 4, our answer will be 5 is to 1.